So polonium 218, let's say, has a half-life. Oh, actually, polonium 218 has a half-life of 3 minutes. Relatively quick. Every 3 minutes, half of the polonium would decay away. And let's ask this question a different way. If I start off with, say, 60 grams of polonium, how long will it take before I get down to 7.5 grams? So how long until we're left with only 7.5 grams of polonium? Well, you can still do this, you can still figure this out in the same way. Start off with what we know, we'll start off with what we have. Start off with 60 grams of polonium, and let's just keep breaking it in half until we get to 7.5 then. So 60 goes to 30, 30 goes to 15, and 15 grams. Half of that, when half of that decays, 7.5 grams left. Okay, you just went from 60, you kept breaking it in half until you got to 7.5 grams, and we know that the half-life of polonium is 3 minutes. So after every 3 minutes, half of it will decay away. So let's just put 3 minutes at each step, if this helps you to write it down. Add them up, 3 plus 3 plus 3, that's a total of 9 minutes. So you start off with 60 grams of polonium. After 9 minutes, you will end up with only 7.5 grams left. And that's because the half-life of polonium is 3 minutes. Every 3 minutes, half of it decays away. Okay? Alright, and so let me just comment on why we use this form of measurement called half-life. Why we talk about how long it takes for half of the material to decay away. Because if you take a look at this example we just did, you might notice that the rate of decay changes. Look at the beginning, after the first 3 minutes, 30 grams decayed away. And then if you look at the last 3 minutes that we did, only 7.5 grams decayed. The same amount of time, 3 minutes, but less of it decayed. So the rate changes over time. So it's pretty difficult to measure the rate if the rate is always changing. And that's because any radioactive material isn't just going to consistently give off the same amount. So like at the first step, if it gives off 30 grams, it's not going to decay another 30 grams the next 3 minutes. It decays 15 instead. If that was true, it would go 60 to 30 to 0, but that's not what happens. And that's because it's based on a probability. Now, here's what I mean by that. In any given sample, in any given amount of radioactive material, polonium in this case, in any given amount, you have tons and tons and tons of atoms, okay? And each of those atoms has some chance to decay. And they all have an equal chance to decay. Now, we can't predict exactly which atom will decay next, but because it's based on a probability, we can picture in the long run what it'll look like. Now, if each atom has some chance of decaying, if you start off with a large amount of them, so at the beginning we had 60 grams, that's going to be a lot of atoms, you're much more likely going to have lots of decay. They all have some chance, but you have so many of them, you're going to get a lot more decaying happen. But towards the end, as polonium is decaying away, you're having less and less polonium left. After 9 minutes, you only have 7.5 grams. You have much less polonium atoms around. And they still have the same chance of decay, but since there's much less of them around, you're going to have much less decaying in the same amount of time. Okay, so that's why at the at the first 3 minutes, you have 30 grams of polonium decaying, but given that same chance, that same probability of decay, once you have a much lesser amount in that same 3 minutes, in that same amount of time, only 7.5 decayed. And if you keep going, it's going to be less and less each time. So you can see that the rate changes over time as your sample size gets smaller and smaller. But what stays consistent is the half-life, when we talk about how long it takes for half of it to decay away. And so each element has a different half-life, but that's an easy way to measure. It's an easy way to estimate what's going to be left, because we know that in a given amount of time, it's going to break in half each of those equal increments. Okay, so that's why we use this funky measurement called half-life.